Hi everybody, thanks for joining me. We're going to try another combination circuit this afternoon. See on my left hand side here I've given you the series circuit rules, the parallel circuit rules, Ohm's law, and Watt's law. And remember once again that when you see a T inside of my circuit, it represents the Ohm's law triangle, so the top of that T would be volts, bottom left hand side is amps, and the bottom right hand side I always put the ohms. I've also on the right hand side given you some reductions here of what this circuit would look like as we reduce the resistance down into one value, and we do that to find our totals often. Now you notice this circuit actually doesn't have any totals, so we're going to have to do some sleuthing to figure it out. I'm going to start up here because I have two numbers. And I look around my circuit, and wherever I have two numbers in a T, it means I can solve for the other one using Ohm's law. And Ohm's law is E equals I times R, or I equals E over R, or R equals E over I. So for this first resistance, I have volts and ohms, and I know that if I divide the volts by the ohms, I will come up with the amps. And in this case, 480 volts divided by 40 ohms will give me 12 amps. And it's the first part of my solution. Now, that 12 amps came out of the negative post of the battery, and that means that it is the total amps for the circuit, which is great because now I know that 12 amps is a total, and I put that in there. When I go a little bit further, I see that R2 has 48 volts and 8 amps, so R equals E over I. I can divide that out, and I can find that I have 6 ohms. One more thing that I can do is, if I think about Kirchhoff's current law, and Kirchhoff's current law says that any current entering into a junction or node has to have an equal amount leaving that junction or node. So if you look right here, I already know that I have 12 amps coming in, and I have 8 amps leaving. So 4 more amps must be going down the first branch. So that gives me 4 amps at R3. Now I have two numbers at R3. 120 volts divided by 4 amps will give me 30 ohms. I look around and I decide that I have to use a reduction to help me in my next step. And the way I do that is I can take and create a new T. So R4 and 5, now those two branches are in parallel, so if I look over here, I can see that I can find the total for R4, 5 if I take R4 to the negative 1 plus R5 to the negative 1, put those in brackets, and take the negative 1 value of that. And when I do that, I look over here and I end up with a value for R4, 5 as 8 ohms. Now I'm going to have to build a new T that represents the totals for R4, 5. So I know that I have 8 ohms in it. I also know that I have 8 amps flowing through it. If you look, I had 8 amps that flowed through R2, so at this junction or node it is shared between R4 and R5. So the total current for R4 and 5 is 8 amps. Total resistance for R4, 5 is 8 ohms. As long as I keep those subs the same, so R4, 5 total resistance, R4, 5 total amps, I can put them in a T, and now that I can figure out that there's 64 volts. If I know that there's 64 volts at either R4 or 5, they're in parallel. Each one will get 64 volts because they're in parallel. And that's great. That's given me some more numbers to work with. Now I can figure out what the current flow is in R5, and it's going to be I equals E over R, so 64 divided by 40 will give me 1.6 amps, and 64 divided by 10 will give me 6.4 amps down that branch. So I have 8 amps coming in, it splits up, I can double check, I should have 6.4 plus 1.6, that adds up to 8 amps, and that's great. That 8 amps is going to come out and go back through R6. So now I know that at R6 I have 8 amps. It gives me two numbers again, 8 volts and 8 amps. And if I look over here at Ohm's law and I'm looking for resistance, R equals E over I, or volts divided by amps, and I'm going to end up with 1 ohm of resistance in there. We're getting close to being done. We now have to figure out what the total voltage is, and there's a couple different ways we can do that. So I look at around any closed loop. So there's a good closed loop. The inner smallest loop means that I'm looking at the resistance of R1 and the resistance of R3. And I'm going to use the voltages from those two resistances to figure out what my total voltage is. 480 volts plus 120 volts will give me 600 volts as a source. I can also double check that because any closed loop will give me 600 volts. So across the source, which is across the negative and the positive, if I take another closed loop, run it right out and all the way back. And what I'm looking for now is everything around that outer loop. If you notice, I'm not going to add R3 or R4 in this circuit because they're not included. They're in parallel already. They're already counted for. So now I have 480 volts from R1. I have 48 volts from R2. I have 64 volts from R3. And back coming this way, I have 8 volts from R6, and all of that adds up to 600 volts. And so it's another way to double check to see if you're on track. I can also figure out the resistance from these two numbers. Now then, my total's 600. Again, using Ohm's law, R equals E over I, so 600 divided by I, which was 12, will give me 50 ohms of resistance for my total. I could also double check that by doing all of these reductions and running down and making sure that I had 50 ohms there. And the last thing I can do is I can use my Watt's law, P equals I times E, so P equals I times E. Thanks a lot.